Hello, this is Ian and Ben with DC Digital, and today we are going to be showcasing our new DC-10C-Rate-AVG assembly line production counter display. So this is a new addition to our rate counters. Basically, it calculates the average rate at which items and products are being distributed in an assembly line. The area sensor detects the objects, or the products, I should be saying. I have Ben over here, and he's going to explain the functions and how the area sensor is meant to work, and I'll take over afterwards and just briefly talk about the hardware aspect of this model.
Thank you, Ian. Here we have the rate display currently with 0 products. The photo eye is what is pictured on the left there in yellow. That is what determines the parts, or measures the parts as they move across it or underneath it. To set up the rate display, you set the interval of time. Currently it's set to 60. We can subtract by 5-second increments all the way down to 5, or increment up all the way up in 5-second increments all the way up to 120, and it does roll around. Once we have the interval of time set, we can pick any one of 4 function modes: function 1, 2, 3, 4, and there's a 5th, which is the raw parts per interval data. I'll be demonstrating in function mode 1, and I'll explain the other function modes here in a second. As the first part passes through the sensor, you won't get anything. Once you pass multiple parts, you can start seeing the rate. If you go really fast, once you get into the hundreds, it does drop over and show 3 positions, so you can measure things up to 4 digits in counts per interval. The interval is anywhere between 5 seconds and 2 minutes. If you have a particular machine going and you need to shut it down temporarily, you can pause it, take care of what you need to, and resume the line. Okay, let's talk about these modes for a second. This product differs from our earlier rate counter products that we've provided for various customers in a number of ways in those functions. However, the 5th function is the same as any other rate counter we've produced in the past. So this one product replaces all of those. It still has the network output option. It still has the relay option. Those are options that you can purchase instead of the default product. Those are not built in this product that I'm showcasing today. Function mode 1 is an exponential moving average, and you can see here on the graph it starts out at 20 parts per minute. I've set all of these graphs with the interval being 60, so I can kind of show how that operates. All of these graphs are intentionally put around a cannery type of environment. So we're starting the line at 20 parts per minute, and then we will ramp up to 30 parts per minute. And then I show how a 1 part gap will affect. The red line that you see here on the graph is the exponential moving average. The blue line on the graph is the data that's based on. So that is the raw PPI data, or raw parts per minute data, that is being averaged out into this exponential moving average. You can see where a 1 part gap affected the count, a 3 part gap affected the count. Then it stables out, and then it tapers down to 10 parts per interval, and then it finishes the line at around 200 parts. In the second functional mode, this is a simple moving average. This average doesn't really look good for a cannery line, and it's probably not the mode that you would use for a very specific machine interval such as a cannery. This would be a good mode to use for an irregular line. Say you have a conveyor and you're unloading a truck onto that conveyor, measuring boxes irregularly as they come out of the truck without those regular machine intervals. This simple moving average averages out 64 of the last time slots to give you a better average of what the line is doing over a period of time. The third mode is a weighted exponential moving average, and the red line here is the exponential moving average from the first graph, The blue line is the weighted line, and what that does is any outliers are weighted differently from the standard, from the regulars. So both graphs follow the same trajectory, except when a part is missing or 3 parts are missing, they're weighted less, so they don't drag down the whole average that much. In the fourth mode, this is a high Q filter. Again, it's an exponential moving average, but you'll notice that the 1 part and the 3 part, the outliers, they don't affect the curve at all. So the red line tracks the exponential moving averages. It rejects the gaps in data and makes the line more realistic to what is actually happening with the line. The last graph I have here is related to the buttons. So if you're viewing the graph in 5 or parts per 5, it would look like the blue line down here. If you're viewing the same thing, the same data over parts per 60, it would follow the green line. And if you're viewing the same data as parts per 120, it would follow the red line. Same data, same inconsistency, same averaging, it's all there, but you can see how it just scales in amplitude with the number of parts or the size of the interval.
So very quickly going over the hardware aspect of this model, as you can see, its enclosure is a black powder coated aluminum enclosure that is fingerprint and dust resistant. We have our 3 buttons right at the top of here, each have their own separate functions. The viewing distance for the digits is 25 feet away, and they are a 1-inch digit, and the number of digits that they each have is 4 digits. The area sensor is connected via a terminal block, as you can see here on the back of the enclosure and the inside. This is how we are able to hook up our area sensor. And last but not least, its power type is a 120 to 240 VAC power wall adapter, which you can see on the right hand side of the enclosure. So again, this is Ian and Ben with DC Digital, demonstrating our DC-10C-Rate average production line counter. Thanks for watching.